Hello, good morning all. I am Ram Mohan, working as Head of Electronics and Communications Engineering Department at Government Polytechnic, Mahbubnagar. The topic is semiconductor diodes. The subtopic is the electrical properties of the insulators, conductors, and semiconductors. The objectives of this particular lesson here is the electrical characteristics of the conductors, insulators, and the semiconductors. Then we'll also understand which materials behave as the conductor or an insulator or a semiconductor. Based upon the electrical conductivity of the materials, they are classified into the following three types. They are the conductors, insulators, and important is the semiconductors. They are actually the evolution of which has changed drastically the scenario of the electronic industry. Now let us see what are conductors. Can anybody tell what are conductors? Yes, the materials which conduct electricity easily are called as the conductors. The examples are copper, silver, gold, aluminum, and many materials. Of course, there are alloys, whatnot, but these are the things that are most commonly used in our industry for connecting and passing the current. See, that is a copper wire bundle, and the second figure is the actually normal cable what we use for electrical connections. That is a copper wire. Then you can see what is this looking like. It is an aluminum cable normally used for very underground high tension very high voltage connections. That is mainly for power transmission. That is called as a cable. It's a armored cable. What is this? This is a silver wire foil. Actually it is wound on a bobbin. The other one is a gold wire. Yes, that is a gold wire. Yeah, so these are commonly used wires or metals which actually are good conductors of electricity. Okay, now let us see what are insulators. What are insulators? They are opposite to that of the conductors. The materials which are very bad conductors of electricity, they are called as insulators. Can you say some examples? Like ceramic, glass, rubber, quartz, etc. So these are insulators. They are actually the ceramic materials. They are normally used in transmission lines and some other electrical connections which are involving high voltages. What is this? The glass pane. It's a glass piece which is also an inductor. Sorry, it's an insulator. These are few rubber rings. They are also good insulators. Even wood, nylon sheet, plastic, they are also insulators. Okay, now let us see the most important material in our electronics, that is the semiconductor. Then what are semiconductors? What do you understand by semiconductors? Semiconductors are those materials which are neither good conductors nor bad conductors, of especially with respect to electricity. Okay, yeah. Some of the examples or the important materials that are used in the electronic industry are the germanium, silicon, and silicon. Yeah, this is a germanium diode, which is normally green in color, and these are few electron components which are out of silica. Yeah, that is a transistor, diodes, and few chips. They are silicon chips. Now let us look into some of the points to remember. The electrical conductivity of a material depends upon the number of free electrons in the material. The conductor has plenty of free electrons, and the insulators will not have any free electrons for conduction. Semiconductors are the ones which have some free electrons. So these are the materials which are having very few electrons for carrying conductors, but under certain conditions only it will allow the current to pass. It will have a conductivity. Let us see into the now let us see the electrical properties of a conductor. Important one is the resistivity of the conductor, and it is very less, and the value varies between 10 to the power of minus 8 ohms per meter to 10 to the power of minus 6 ohms per meter. That is 10 to the power of minus 8, means 1 by 10 to the power of 8. Well, the conductivity of the conductor is more. Conductivity is the property which will tell about the ability to allow current to pass through it, and normally that is inverse of resistance. And when you look at the resistivity, it was 10 to the power of minus 8 to 10 to the power of minus 6. Here the value is ranging between 10 to the power of 6 mhos per meter to 10 to the power of 8 mhos per meter. Yeah, that is inverse of ohm. Fine. Right. And in the conductors, there will not be any forbidden gap between the valence band and the conduction band. And these conductors normally have one or two or three free electrons in their valence band. Now let us see the electrical properties of the insulators. The resistivity of the insulator is more. It lies in the range of 10 to the power of 12 ohms per meter to 10 to the power of 18 ohms per meter. You can say that is very high value. And hence the conductivity is negligible. it is the inverse of resistivity, so the conductivity of the insulator is negligible, and the range between 10 power of minus 18 moles per meter to 10 power of minus 12 moles per meter. The forbidden gap energy is up to 6 electron volts. They have fully filled valence band and conduction band. Let us see the electrical properties of the semiconductor. The resistivity of the semiconductor is less than the insulators but more than the conductor. It lies in the range of 10 power of 0 ohms per meter to 10 power of 2 ohms per meter. 10 power of 0 is 1, so it ranges between 1 ohm to 100 ohms. The conductivity of the semiconductor is more than the insulator and less than the conductors, and it ranges between 10 power of minus 2 moles per meter to 10 power of 0 moles per meter. And these have partially filled valency band and the conduction bands. The forbidden gap energy in the semiconductor is up to 1.1 electron volt. Now let us see the summary of this. We have discussed about the behavior of the materials as the conductors, as insulators, and as the semiconductors. We also discussed about the electrical characteristics of the insulators, the conductors, and the semiconductors. Do we have any doubts? Let us check ourselves. How much is the forbidden gap energy for the semiconductor? 20 electron volts, 6 electron volts, 1.1 electron volts, or 0 electron volts. Which one? It is 1.1 electron volts. Okay. Yeah. Now, in the given below materials, which is a conductor? A glass, germanium, silicon, and a copper. Which material? Obviously, it is copper. What is the forbidden gap for an insulator? It is 0 volts, 20 electron volts, 1.1 electron volts, or 6 electron volts. So the forbidden gap for the insulator is 6 electron volts. Let us check what we could remember. A conductor is dash conductor of electricity. What's it? It is a good conductor of electricity. At room temperature, semiconductor behaves as and insulator, because it has got about 1.1 electron volt. A semiconductor has dash filled valency band and conduction band. Full, empty or partial? It is partially filled, both the valency and the conduction bands. What is the resistivity range of conductors? It is 10 to the power of minus 8 ohms per meter to 10 to the power of minus 6 ohms per meter. Now, what? Yeah, conductor is having a forbidden gap energy. Is that true or false? For a conductor, it is no. There is no forbidden gap in the conductor or metals. They are overlapped energy bands of valence and conduction. Let us look into the frequently asked questions. State the electrical characteristics of conductor. Mention any 4 electrical characteristics of an insulator. Then list the electrical characteristics of a semiconductor. Okay, yeah. With this, we will conclude this session.